Hello, I'm Todd. Welcome to Research Pod. Humans are social creatures. We live in family groups, socialise with friends, and work with colleagues, both in person and online. Yet, how many friends do you really have? Evolutionary psychologist Professor Robin Dunbar says it won't be more than 150. Proposed in the 1990s, Dunbar's number puts a limit on the number of stable relationships that humans can maintain at any given time. In the internet age, this number might seem on the small side, but Dunbar's theory is tried and tested, where his social brain hypothesis suggests that brain size is directly related to social group size in mammals. In short, the bigger the group, the bigger the brain. In this interview with our sister publication, Research Outreach, we find out how Dunbar's education moved from philosophy to psychology and how his research moved from primates to people, as well as why size matters when it comes to social groups and evolution.
If we go back to the beginning, I actually went to university to do philosophy. That's the only thing I was really interested in. I come from an arts background and wasn't the slightest bit interested in the sciences. All my UCAS applications, bar one, were for pure philosophy. And the bar one was Oxford, where, of course, you can't do philosophy on its own. So I ended up going to Oxford. I considered all the possible options and decided the idea of doing grades or PP was just unbearable. And the least bad option was what was then a new degree, which now no longer exists, which was PPP, and I did philosophy and psychology. And I marvel to this day that had I gone anywhere else, I would probably now be a very bad second-hand car salesman and retired in Blackpool or something. Clearly, as I discovered, you needed a very big brain the size of a planet to do philosophy with any hope of success in the sense of academic posts, as it were. So psychology introduced me to the sciences in a way which was much more meaningful, because obviously in those days, the only sciences you could do kind of physics, chemistry, and biology, basically. Things like psychology didn't exist as A-levels. So psychology introduced me to something slightly more interesting. Well, I was relatively competent in physics because so much of philosophy of science was based on physics. And that I had read a lot about. So I was kind of familiar with physics and the maths of physics. And as it happened, the first year, basically, for psychology was taught by Tinbergen and people in his group in zoology, so it's animal behavior. So that introduced me to something completely different, completely out with my fields of knowledge altogether, animal behavior and even ecology. But it resulted in me doing a couple of university expeditions to study animals in Africa, my summers of my second and third year, and then doing a PhD on primate behavior. So I really, via psychology, got seduced into the sciences, but into kind of ecology and animal behavior and the evolutionary sciences. And so the first half of my career was actually spent studying primates and ungulates, antelope and the like, in the wild, in Africa and here in Britain, latterly. And it was only kind of late on in the 90s, late 80s actually, during the Thatcherite squeeze, when there were no academic jobs and there was no research money to do field work. If you were promising to cure cancer, of course, they'd give you money, but to do trivial stuff like watching animals in the wild. So I just figured I'd do what we did on monkeys, on humans in the wild. I mean, literally in the park. Observational studies of humans, and that kind of pulled me off into humans. That's when, in the context of that, I kind of came up with the evidence for the social brain hypothesis, which itself was an accident, complete accident, because I was interested in trying to solve another much more trivial problem, which is why primates spend so much time grooming, because the general consensus at the time was that it was purely hygienic, which it obviously is. It has a hygienic function, but many years of studying monkeys in the wild, and particularly very social monkeys, have made it clear this was more than just hygiene. And so I was trying to find a way of testing between these two hypotheses. In the context of that, it dawned on me that since the Machiavellian intelligence hypothesis had just been proposed, that actually we could wrap that in a three-way correlation, if you like. And that indeed turned out to be true. Time spent grooming by primates is correlated with group size, and group size is correlated with brain size. And that produced the social brain hypothesis and the prediction of Dunbar's number. And after that, it's history.
Yeah. The way that you describe coming to sort of find your specialism sounds like you were fairly open to sort of learning new things.
Yes, that's an interesting point, actually, because I've always argued that the one big benefit I gained from philosophy, which I did enjoy really, was to ignore other people's disciplinary boundaries. That if it's interesting, the kind of, as it were, mantra of philosophy is, if it's interesting, do it. And if it means transgressing on other people's disciplinary boundaries, ignore them. They won't like it. They'll hate you for it, but ignore them. And I guess that then combined with having done a degree in psychology, which is clearly focusing on the mechanisms of behavior, as it were, the mind and other aspects of physiology that determine how we behave, and then also being immersed in essentially zoology and to some extent botany, even plant sciences, and an evolutionary perspective on that in particular, where you're looking at the functions of behavior, not necessarily just the mechanisms. The combination of those two became very important because it then allowed me to look at the organism both top down and bottom up, if you like, at the same time, which was not very common. It certainly wasn't in psychology, because psychologists ignored evolution since, I think the guy's name was caught with his trousers down anyway in a brothel in Boston, something like that. One of the great turn of the century founding fathers of psychology, who was very much enamored of evolution, but he got forced out of his job, and that caused psychology to lurch away from evolution into essentially physiology, the arms of physiology, and become much more mechanism oriented. Psychology kind of ignored functional questions, whereas by and large zoology, animal behavior, it's sort of, not entirely, but sort of ignored mechanisms of questions. So I kind of saw myself as doing both. And that kind of resulted in my working on everything from genetics and ecology at one end to the evolution of things like social systems. So what I see myself as having spent the last 50 years working on is the evolution of sociality in these highly social mammalian and bird species broadly. I've worked on insects as well, but most of my time has been on very social mammals and to a lesser extent birds. Spread my taxonomic interest much more widely than most people have, but also the questions I ask are definitely much wider. Yeah. And I see it as literally trying to fill in an enormous jigsaw puzzle with different bits of the jigsaw puzzle, representing not just taxonomic variability, but the different kinds of questions you can ask. So if you look at my career, I spend a certain amount of time up in one corner of the jigsaw puzzle, fiddling about, and then move off and work somewhere else, depending on partly graduate students and postdocs, but also collaborations. So over the last 20 years, if you look, my collaborations have expanded way outside conventional behavioral ecology, if you like, and psychology into neurosciences and neuroimaging. And latterly, in particular, a lot of collaborations with mathematicians and physicists, statistical physicists. So I actually held a visiting chair in statistical physics for a while at another university. And the latter is particularly related to understanding social networks, because physicists were doing a lot of the running and developing ideas and on those. But I mean, most of those people have come to me. I don't go out looking for them, knocking on their doors. People have come to me and said, will you be part of our project, as it were? And that's been proved to be very enlightening, a lot of fun, and a lot of what the story as it's built up has been a consequence of these collaborations with outlandish people that sensible people would never have any truck with. And even, sort of at the other end, I have had and still have collaborations with historians. A paper published earlier this year on Icelandic Vikings, medieval Icelandic Vikings, but also drama people. We had a big project running in Oxford on, if you like, the psychology of drama, with a Shakespeare person and a classical Greek tragedy person. So I do spread my wings. Yes. If it's interesting, yes, let's do it.
Is that sort of attitude, because as you said, when you were first approaching university, Oxford doesn't do straight philosophy, so you have to sort of improvise to some degree to combine that with something. In your own teaching, is that something that you take towards your own teaching?
That's certainly been true, because in the end, a lot of the teaching you do at university is based around your own research, inevitably, and you couldn't possibly understand what I do or why I say the things I do if you didn't see those disciplinary interconnections, I guess. So, it becomes necessary. And besides which, I think it is important. I mean, I think the worst thing you can do is be a one-channel educated person, as it were. Well, there are some things where you have to do that. I do think that's something you have to do in math. You can't develop the level of mathematical skills, and maybe that's true of physics, if you don't, if you start doing theology or something.
Yeah.
You can't come into it late. You've got to, from childhood practically, be dragged up through this one channel. Hopefully you can bump into people who can drag you kicking and screaming into other fields with your skills, which is what I view my interactions with physicists and mathematicians as being. But, I think the worst thing you can do for most fields is stay in the same channel for the whole of your life. It's much more beneficial to switch fields. It's not that easy to do, slightly more easier in some places than others. And Cambridge, dare we even mention the place, with the tripos system, you have to start much broader and then narrow down. Or if you go to the Scottish universities, you've got an American type system, or should we say, to be correct, the American system is based on the Scottish system. So it's a 4-year degree, with the first year being cross-faculty. You have to do. I mean, you might go and do a degree in philosophy, but your first year, aside from philosophy, you have to go and do stuff in other faculties. And that's true for the sciences. They have to do an arts, a humanities course, and so on. It's in a way, a bit like the old PPP exam or degree, because the prelims course for the first 2 terms, we actually did no psychology at all. We did a course in logic for philosophy, and a course in statistics, which was very useful, and a course in animal behavior. There's no psychology to be seen. And I actually think that was extremely good. And both of those, I mean, all 3 of those were 2-term courses. But that's kind of rare, even at Oxford, because, grades and PPE are a bit like that. But most degrees, if you're going to do French literature, you go in to do French literature on day 1, and you've come out 3 years later, still having only done French literature. But there are kind of advantages to having a sort of broader base to start with, not so much narrowness and specialization early on. The problem is it's a trade-off, because if you don't have the skills and the knowledge, that imposes limits on you later down the line. How much, the whole point of specialization is to provide people with early specialization. If you go back to the 60s, when I was an undergraduate, you could go straight into a PhD off a degree, an Oxford degree certainly, but all university degrees, because you were already, by the 3rd year, you were at research level. I mean, I had done 2 independent research projects, both of which were published by the time I'd finished my undergraduate degree. By comparison, at that stage, American students were regarded as just not up to it. They needed to do a master's degree before they were up at the same standard as our undergraduates. That's no longer true, sadly.
Is a master's quite a new phenomenon in the UK in that respect? Yeah.
Absolutely so. I mean, the master's degrees of a kind have always existed. So the MPhil and the MLit degrees have always existed, for example, at Oxford. but they were tended to be more directed towards, I don't know, vocational things or switching things. So you couldn't do a degree in anthropology in the 60s, but you could go in to do anthropology or geography and various other, you name it, any degree you wanted, as a PhD, but you usually did a sort of MPhil conversion course to give you a bit of a grounding. And that's what I think those degrees function mainly for, probably, or people who are going off to be vicars.
Yes.
Or maybe teachers, who wanted to just do a bit more intellectual stuff on the way. But then it's become much more common now, where it's practically de rigueur that you have to do an MSc before a PhD. I mean, you could argue that that's because degrees have been watered down, or you could argue that the world has just got more complicated, right? So there's more to learn. Okay, you could go from an undergraduate level to a PhD in the 1960s because there was just that. The world of knowledge was that much thinner. There's less to learn. Whereas now it's become much more complicated. But I mean, maybe that's the place where you should be doing a different field, dip out and learn something else.
In a similar vein to how that's sort of changed in your lifetime, I was wondering how, especially with like AI and technology at the moment that's sort of burgeoning and very present, I was wondering how you've seen your own field change in your lifetime. Has that been sort of quite a present thing for you to notice, or do you have to take a step back to really analyse what's changed?
I mean, there is no question, but if we take the field of animal behavior, which I would kind of see myself as where I mainly sit, I mean, it's sort of, it's the gap between the zoology on the one hand and psychology on the other. It's the overlap zone in a way, rather than a gap, perhaps. But, that has certainly changed dramatically, partly because of the selfish gene revolution back in the 70s, which was a generic shift by everybody. I think, it was sort of encapsulated in Richard Dawkins's book, but, with the best will in the world, I don't think we could say he was responsible. He was certainly responsible for proselytizing it, but I mean, it was clear, because that was when I was doing my PhD, everybody was kind of making that shift around the same time. That's certainly been true. Genetics has made a lot of difference. Molecular genetics, the appearance of molecular genetics, and also neuroimaging. Neuroimaging has made a huge, huge difference to our understanding of how the brain does stuff. It's still very murky, but it has really changed things. So those kind of technical changes, I suspect, there has become much more interdisciplinary interaction. That's also true, I think, because partly as a result of that. And that's been very beneficial. And all of them have become much more heavily mathematicized, which also has been a good thing. But I'm not sure there have been major intellectual changes, realistically, major paradigm shifts since the selfish gene switch from essentially a switch from group selection to individual selection.
And sort of going forward, do you anticipate any major paradigm shifts that are on the verge at all? Is that too difficult to say? I don't know.
That's always impossible to say until after the event. 20 years later, you can look back and say, oh my goodness. I mean, I never realized that at the time. I mean, I suppose the social brain was, in some sense, a bit of a paradigm shift within a field, as it were, because it switched attention from very simple level mechanisms to what are clearly much more complex decision-making processes that involves something much more complex than just memory and counting and instinct, which is, I guess, how animal behavior and to some extent human behavior, but how animal behavior certainly would have been seen until really the 1990s. And I guess that also has kind of opened the way more for a view of social evolution as being something rather more interesting, and the group level phenomena, in other words, not so much cooperation, but the benefits that accrue through group living, and the fact that group living is extremely difficult to do. all these have been massively underestimated, I think. So the switch from group selection of the 1950s to individual level selection of the selfish gene, in some sense, I mean, it was highly desirable and very valuable, but it kind of went a little bit too far because it caused everybody to forget about the fact that some animals live in groups. Quite literally, I think, groups became, whereas group living previously had been seen as, in many ways, the most important component of animal behavior, that kind of vanished. But as a result of the kind of stuff on the nature of the social brain and looking at groups as part of the adaptive suite that some species, especially mammals and birds, but in particular the primates, or mammals and birds generally, but particularly the primates, have exploited, as it were, these group level opportunities, is swinging back into fashion, I think, slowly. But the problem is that it still suffers from a sort of murky past of association with group selection, which you are still not allowed to discuss.
You also cover relationships and parallels between humans and animals, and I guess mammals generally, and cover things like love and betrayal. I was wondering if you could very briefly tell me about that side of your research.
Yeah, well, I suppose this all goes back to this sort of top-down and bottom-up approach that I have, in that I'm kind of interested in social evolution primarily, and that pushes you towards looking at group level phenomena. But once you understand that groups don't come out of nowhere, they are extremely difficult to engineer, and that underneath, they are the consequence of relationships animals have with each other, and that relationships are extremely difficult to engineer, as humans ought to know. Some humans certainly know. It just pushes you, and I guess it goes back to my mantra always, apropos of Tim Bergen's Four Whys, his famous four questions, which originally derived from Aristotle in his Anima volumes. He was the first person to point them out, and probably the greatest evolutionary biologist before Darwin by a long shot. Because what his biology was absolutely stunningly good. He really understood what he was talking about, and it's primarily because he was really the first person who actually looked at animals. He would go down to the fish markets and poke about in the trays of fish that the fishermen had brought ashore and dissect them and stuff. And he got some stuff wrong. God's sakes, it was 2,500 years ago, and he didn't have a microscope. But he got some evolutionary principles right that weren't rediscovered till the 20th century. Remain completely overlooked. So he was exceptionally good, and he understood this whole point that biology consists of layers of explanation, the different questions that became associated with Tinbergen's Four Whys or Tinbergen's Four Questions. But that, the essence there is you should just be constantly asking why is X the case, and that naturally pushes you down and down and down through the layers of biological explanation, down into mechanisms and therefore emotions, down into the machinery of the organism. So it's really in the context of recognizing that groups arise out of relationships between individuals, that they have to work very hard to maintain the cohesion and stability of groups through time, and that depends on their relationships with each other. That sort of pushed me down in that direction. You're now very much into the territory of classic psychology, really. So I suppose at least I could claim I had a grounding, and therefore it was questions that were interesting to look at. But I suppose I kind of really got interested in the kind of romantic relationship side simply because in the Thatcherite financial squeezes, when there wasn't any money to do anything, one of the things that I lit upon, and I can't remember how or why, but I think it was one of those chance things when I was looking at newspapers, because in those days, aside from things like Loot and stuff in London, those kind of magazines, which would be packed full of personal ads, all the major papers, would have a personal ad section, particularly in their magazine sections. And, just leafing through those out of curiosity kind of made you go, my goodness, look at, here's beautifully succinct little packets of information on what people are looking for. So we ended up in the 90s doing a lot of analyses on personal ad columns, looking at mate choice strategies was a major feature of behavioral ecology. So, it was in response to that. I mean, normally that was being done on animals, but how many eyes have you got on your peacock's tray that attracts females? And not very little was being done perhaps on humans. So it was very early on that transition into mate choice strategies in humans made us start to look at that. And at that point, I was clearly thinking along these lines generically, because we also started doing analyses of folk song compilations. So the kind of classic folk songs that were proper folk songs, not Woody Guthrie, 18th and 19th century folk songs that the collectors of folk music in the 19th century, early 20th century had assiduously gone around and collected from old Mother Hubbard, old Jim Scarecrow, sitting in the corner of a bar, and written down. And that dawned on me that in these songs, again, you had this very, very nice little encapsulation, because the song is short, people's concerns, and most of them are about romantic issues in one form or another. So there's a kind of way into collecting data which actually didn't require any funding. It required us a bit of time. And that was how I got into the Icelandic Viking medieval family sagas as well. I was actually listening to a performance on, I think, Radio 3 of Njarl's saga, which is all about the Njarl's family and this huge vendetta that they got involved in. And it had been done as a radio play. And I was just sat there mesmerized by this, thinking, my goodness, the sheer detail that's actually in the sagas that you could mine, as perfectly good data on human behavior. Because even if it's not entirely true, although in fact the family sagas can be validated against archaeological and historical data, so most of them are actually quite accurate. But even if they were fiction, it's how people think. It's giving you insights into what's motivating people, as it were, how they engage with the world, how they think about the world. So that's when I did the first of the Viking papers, was back in the early 90s.
You went back to like Aristotle and noted his sort of using experience in a way to sort of interact with the world and see how it works, and to analyze fish and everything like that. And in your own research, using the materials around you, like you said, not really needing research funding. Is improvising like that common in your field, or are there a lot of people that are a bit frustrated?
Not very, partly because there's much more money available now, for things aside from curing cancer. So, everybody's can do projects which are much more focused. I think that probably discourages people from being creative and imaginative in that sense. But there are, it seems to me two things are broadly important here. One is that the distinction between the humanities and the sciences is kind of false in a sense. I mean, it's deeply rooted. And indeed, I always claimed I was the origin of C.P. Snow's two cultures. I was humanities born and bred, and would never dirty my hands with this stuff called science, which is clearly very boring stuff, and then discovered it was actually quite interesting. But there is a perfectly correct interpretation of science, if you like, in the Greek, which covers all these disciplines. They are trying to explain something about the world, whether it's how Racine composed his plays or bits of history for historians or what have you. They're all trying to explain something that's going on out or went on out there in the world. And therefore the modes of evaluation of hypotheses have to be empirical in the end. And I suppose I come from a tradition where because I took the history entrance exams to get into Oxford, which was my main subject. And so in some sense, I have, a third leg or arm or something in history as well as the main disciplines I do. But that was very much in the context of the debate in the 60s about history being an empirical science. Collingwood and all these people kind of thinking about the philosophy of history, historians thinking about the philosophy of history and kind of making these arguments. And then one of my tutors in philosophy as an undergraduate, his main field was philosophy of history. But I was kind of much influenced, I guess, by osmosis, without sort of spending a lot of time thinking about it, by this background. If you're talking about history is there, it's in the ground, or it's there in documents. If you want to make a claim, it should be provable in some way. It was the high point of Popper and all the Lakatos and all these people in the philosophy of science down in London. They weren't allowed to come near Oxford because Oxford did proper Oxford philosophy. But still, the idea that if anything we do, by definition, engages with the real world. So it's subject to evidential criteria of the real world. Even when we set about writing fiction, as it were, it's based on our experiences out in the real world. So there are empirical questions to ask about how good fiction writers, dramatists, whatever, are about their understanding of how the psychological world of their audiences or their readers tick. Are they constrained, for example? So we've done a lot of work on this over the years about, are dramatists constrained by the cognitive limits of their audience in what they can get down on paper? It may be imagination, therefore something that's never happened. You invent an imaginary story, as it were. But still, it's very difficult to get away from reality, because if it becomes too implausible, it's not believable anymore. Like religion. You can do things in religion. I'm thinking of, sort of how charismatic founders of religions and saints and people like that are glorified. They're glorified very often by being able to do superhuman things that normal humans can't do. They can walk on water, they can pass through walls, all these kind of things. They can do miracles. But they can only do ones which are reasonably plausible. They are bound by the human engagement with the real world. So you never find founders of religion who, stick jet engines on their backsides. Reality intrudes. So that kind of one of the things that got me into spending a lot of time working on religion and the evolution of religion. Because here was something which, when we started to look at how humans create bonded social groups, so the big problem that mammals have, primates have in particular, and they've solved it, if you like, is how to keep these groups together against the forces which drive them apart. So, this is the central idea here, is exactly the model of the atom, as it were, particle physics. There are weak and strong gravitational forces, and there are weak and strong anti-gravitational forces. And what you get all depends on the balance between these. And you can see them at work in primates, at least we can now that we've realized that that's what's going on. And the big problem you have is how to keep groups together, because there is this very strong dispersive forces, anti-gravitational forces. And particularly so when you have very large groups like we do. So what you then see is humans in discovering mechanisms that allow them to exploit the bonding mechanisms that are used at the individual level, but on a larger virtual scale. So we got very interested in what these were, and basically we spent a lot of time working on what seemed to be 6 major bonding processes that come into play. And one of those was clearly religion. Kind of got me very interested in what on earth was going on here. Why does religion work? So far, it's not got me fatward, I hasten to say, but despite having done my best.
Tell me a bit about Dunbar's number and how that theory sort of came about and how you see it being relevant still today, because obviously that was quite a while ago now.
Okay, so Dunbar's number is simply the limit on the number of meaningful relationships that you can have at any one time. So it's not fixed in the sense that the identities are fixed. It's the membership of this set is dynamic over time. It changes. Some people more than other people, but does change over the course of a lifetime. But the number seems to be fixed. It's always about 150, although it varies between some individual variation between that, which we know a lot about now. Part of it's due to personality, not too surprisingly. Some of it's due to sex, but in rather more complicated ways. So extroverts have a bigger Dunbar number than introverts. Women tend to have bigger inner circles than men, but men tend to have bigger outer circles. But again, these are not enormous differences. But and circumstances dramatically affect it too, what your opportunities are. So migrants tend to end up with very small social networks until they've embedded. That can take several generations. But that's why you get ghettos arising with migrants primarily. All right, so how did we get there? That came out of trying to, as I mentioned earlier, trying to understand why primates spend so much of their time grooming each other, social grooming, and the realization that that must have something to do with the brain, because it had just been proposed that the reason primates have such big brains is the fact they live in very large, complicated social groups. And that was the hypothesis that grooming was part of the bonding mechanism. So to test the hypothesis that brain size, so the evidence for the social brain hypothesis as it was then, which was really the Machiavellian intelligence hypothesis, which is somewhat different in its kind of orientation, was the evidence was kind of casual and qualitative. And it just occurred to me, since I was testing quantitative hypothesis for grooming, that actually we could look at group size in relation to brain size in primates would be a test of the Machiavellian intelligence hypothesis. But it was already at that point beginning to change in my mind from being Machiavellian, which is exploitative, to being about social coordination, about being able to live in groups. The problem with the Machiavellian intelligence hypothesis is it actually cannot explain the evolution of groups. There's absolutely every reason for not living in groups if we were being exploited all the time. But as something that might emerge afterwards, as an evolutionary window of opportunity, as it were, then it made much more sense. So you still have to explain why groups evolved. But the relationship between brain size and group size, when that sort of came out of the printer on the computer, I think we were doing it on a computer. It was just at the transition between doing everything on paper and doing it on a computer. It just occurred to me that we had the database we use is still really the best one there is for brain size in primates, had humans in it as well. And out of idle curiosity, I wondered what the relationship for primates would predict for humans. So I plugged humans into the regression equation that came up with this number 150, which I then spent many weeks trawling through ethnographic journals and books looking for data on hunter-gatherer group sizes. So at that stage, we had no idea what the natural grouping size for humans might be. For most primates, many animals, but not all. It's obvious what the group size is because it's very stable. Primate group size is very stable, not for all species. And also I'd worked on a species of primate where group sizes were highly multi-level. So I guess I was primed to thinking in terms of these hierarchically structured social systems. So much more labile, difficult to kind of figure out which of the many layers is the basic layer, as it were. And then at that stage, I was in an anthropology department, and I knew enough about anthropology because actually I'd been interested in it, having grown up in Africa anyway. But I'd always been interested in ethnography and anthropology and knew a fair amount about it. I thought the answer is, we just need to see what numbers are on the table in terms of the ethnographic literature to see if anything corresponds to about 150. And sure enough, there was. It was this kind of rather nebulous concept of a clan, essentially, halfway between a band, which is the camping group, and the tribe. Well, it's in the middle, it's not halfway. But that was bang on this number of 150. And then after that, we started collecting data on social group sizes. At that point, we hadn't realized that these groups were highly structured in this way. could see in hunter-gatherers that they had these different levels of sociality, as it were. We did realize that your social network is also structured in the same way. But once we had several sets of data on people's actual social networks, we'd ask them to write down all the people they had meaningful relationships with to try and see if we could replicate this number or not, or if it replicated this number or not. But we also asked them, well, how do you feel about them emotionally? How often do you see them? And then it became obvious that actually networks are not homogeneous. Your social network is not homogeneous. It's highly structured. Then took us a very long time to show, because the statistic, how you would show that statistically, was not very obvious. The techniques to deal with it, which is cluster analysis, were available, but not widely available. Not the kind of things mere psychologists knew anything about. Physicists would be doing that kind of stuff, probably. So it took me about 20 years to figure out how to partition networks in this sort of way. And at that point, all sorts of things popped out, because then it turned out not only do we have huge numbers of samples showing that, some based on enormous samples. I think the biggest one is 61 million Facebook pages. And the average number of friends on those 61 million is exactly 149. On the strength of which I always claim I'm going to go past go, collect my $200 and buy both of Abramovich's yachts. But then it also became clear that they were highly, highly structured in these layers, your social networks, and that these layers in the social network are identical to the layers in hunter-gatherer social organization. So we were looking bottom up at social networks, and hunter-gatherer data are looking top down on how people are distributed in the environment. And you're getting exactly the same numbers. And it turned out that these numbers just occur in all our data sets. So we looked at lots and lots of different data sets, telephone data sets, mobile phone data sets, let's say, Facebook data, Twitter data, you name it. We were getting exactly the same numbers. And then they turned out to be the same numbers in primates as well. So primates basically only have 4 group sizes, some variance around it, but essentially then 4 group size clusters. And those primates that live in big group sizes have highly structured social groups. If you look at grooming patterns, for example, and the sizes of the substructured clusters within the groups are exactly the same as the sizes of the groups that less social species live in, and they're the same numbers as you get in human social networks, exactly the same number. And then it turned out something I had suspected all along, but again, we couldn't prove until we had these statistical tech tools available much 20 odd years later, was that actually the social brain is not a single homogeneous data set. Blatantly obvious when you look at it, really. Well, and in fact, in 93, I did show that it couldn't do much more than that. And actually, it consists of 4, maybe 5 separate grades. And what the grades are, cognitive grades, essentially. So, you can increase group size by increasing brain size, but only so far. You just hit the buffers, really. Everything starts to fall apart once you get group size too big for that grade of brain size. And what you have to do is to shift onto a new grade, which opens up a whole bunch of new cognitive abilities. So you've got a sort of zigzag pattern. If you look at the distribution of species on these grades, they follow a zigzag pattern where they go up so far, and then species that stay on that grade and go beyond it have very incoherent social groups. And the sensible ones have sidestepped onto the next grade, use the capacity to increase brain size much, much faster to introduce new cognitive abilities. And now it turns out this is true of carnivores. We always thought this was peculiar to primates, the social brain hypothesis. Well, it's kind of unsure, but my instinct was this is all about how primates bond their groups. And unless other species bond their groups in the same way as primates, they're not going to be forced to find the same solutions. But we've just shown that actually carnivores sit on the primate social brain grades exactly the same way, and so do insectivores, just they're on an even more primitive set of grades to the left. So there are actually a whole series of grades that are associated with the cognitive capacities opened up a bigger computer, essentially. So the whole story's become much, much more complicated at various levels. And that's kind of raised the questions about how different species solve the problem of integration, the trade-off between grooming as a bonding mechanism and a kind of pharmacological basis for creating relationships. And grooming component is going on in the brain too, it's the endorphin system. But the cognitive element that's used by the species that live in very big groups, in primates in particular, where they're exploiting a dual process system. In fact, what they're doing is actually bonding and we do the same, bonding with our close friends in the age-old primate way, which involves the endorphin system primarily, and then using cognition to build kind of more abstract virtual relationships with layers of the group further out, so the outer layers. And you can see this, and you can show that this is what happens in some of the more social primates as well. So it's all become very complicated, which is even more interesting.
Yeah, yeah.
My big problem is nobody ever reads the literature that we turn out. And there are all sorts of attempts to show that the social brain hypothesis doesn't work. It's nothing to do with sociality. It's all to do with foraging. You kind of go, have you never heard of Aristotle? It's all about Tim Bergen's 4 whys and levels of explanation. And also that Dunbar's number doesn't exist. It's kind of ironic because everything that I've explained to you, all these complications, are actually there in my original publications, 93 and 98 publications, or the second and the third, not the original social brain one, but the one on humans, and then the kind of overview I did in 1998. It all spells this out because we couldn't show it, but this was the kind of intuition I'd come to. So trying to understand what was going on. So all these complications are all in there. And you kind of go, nobody's bothered to read any of the literature we've written. So I was asked, there's papers just come out actually, there's a human anatomy journal, human biology journal, it's the 30th anniversary special issue. They asked people published before to kind of do a short 1,000-word reflection on the original paper. So it was on the social brain stuff. I was kind of listed all the different features. There's about sort of 15 different bulleted things that have emerged over the years, and then said, it continues to baffle me when people criticize the social brain hypothesis or Dunbar's number. They base it on not having read the original papers first. And they clearly haven't bothered to read the 265 papers we've written since on this subject. So I don't know what they're talking about. It's got no relationship to reality.
Yeah. Have you found that if you were sort of theorizing about Dunbar's number today, would you approach it differently at all? You said
no, because it turns out to hold on the internet, on social media, even turns out to hold in online gaming worlds. These constraints, the interesting question was, would it hold on the online environments or not? Because online environments, 1 argument would be, well, it's a largely constraint of face-to-face interaction. That's how we've always done it, and you can only talk to so many people at once, as it were, because everybody else you've got to go and walk half an hour to their house to have a chat with them. And that could be the constraint rather than a cognitive constraint. And so the question is, well, if you remove the communication constraint, which is essentially what you're doing on social media, talks to many people at once, does that allow you to have a bigger network? And the answer is no, it doesn't, because you see exactly the same layers. Yes, some people, will have 1,000 people on their Facebook page, but actually all they're doing is including the layers outside the 150, because we know that structure is that what's been referred to as a Dunbar graph, in the mathematical sense of a graph. These circles of relationship, they run out on this very, very strict rule of 3. Each circle is 3 times the size of the layer inside it. They ran out to 5,000 and they stopped there. 5,000, that was figured out quite independently, unwittingly, by some psychophysiologists who are vision people interested in what was the limit on the number of faces we could recognize. Seen before, turned out to be 5,000, which just happens to sit perfectly on the end of where we had got to, which was 1500 was the biggest layer we knew about, which is the size of a tribe, and had been shown many, many years ago to be a number of faces you could put names to, as opposed to just say whether or not I've seen them before. It's too complicated, this stuff. Well, I think that's the problem. I think in some sense, this is a tribute to philosophy in that, my capacity to hold all these complications together, as it were, are a consequence of training in philosophy as much as anything. Can see no other reason why I can do it. But it does make it very difficult, because I'm very conscious also in philosophy that philosophical thinking, particularly of the Oxford tradition, was very much built around simplifying things. Keep it simple, because people didn't say this, but this is clearly the issue. Your capacity to handle complexity is very, very cognitively limited. So, or for people, so simplify everything down to two nuts and bolts, and then try and build it back up again, if you like, which is all I've kind of really done. But I'm very conscious of the fact that people find that very difficult to do, to handle a multi-dimensional. You're dealing with a multi-dimensional universe. They find it difficult enough to deal with a two-dimensional graph, never mind a multi-dimensional graph that, comes out at you off the page. So I'm kind of sympathetic to people's constraints in these times, but also I find it very frustrating. Back to the internet, it did just all the evidence points very, very clearly to the fact that you don't increase the size of your social circles. All you do is implement what exists in the real world. So we have these layers out beyond 150. We know what they are. They're at 500, they're at 1500. The principal ones, we know exactly what they consist of. The 500 layers acquaintances. So it's not terribly surprising if some people, have 400 or 500 people on their friends on their Facebook, or used to, if anybody still uses Facebook. Maybe that's why they're all on WhatsApp, because you can keep smaller. But all you're doing is including kind of acquaintances, voyeurs onto your social life, because you don't actually address. You look at the postings, these people out there don't get addressed very much. They just sit there in the background. And that's why, if you look at the distribution as a whole, we haven't done this because we don't have the data, but my guess is if you look at the actual distribution, it's not a single normal distribution, or even most of these things are Poisson distributed anyway, so they have a long tail to the right, the peak somewhere over to the left. And what we showed we've showed it with telephone data, we've shown it with residential campsites, let's say trailer parks in Germany, which is a lovely data set and quite bizarre. Various other data sets. What you're dealing with here, the social brain data and data on social network are not single homogeneous data sets, not a normal distribution. And if you partition these data on the basis of their sizes, what you get is exactly the 4 grades of what the social brain data have turned out to be. So if you look at the distribution of group sizes that people actually have, so the average allegedly number of friends on Facebook is 149, with a range of variation probably from about 50, 80, somewhere there, up to about maybe 1,000, but predominantly you don't get much past about 400, 500. Actually turns out that they fall out into a series of patterns. It's not a continuous distribution, in other words. What you're dealing with is consistently you get 4 Poisson distributions, slightly overlapping, which is amazing, really. And those 4 Poisson distributions, the peaks turn out to be the midpoints of the primate grades in the brain size data. So it all hangs together beautifully, mathematically, which is why I'm always very laid back with idiots who insist on. It's quite useful to have people challenge these things, because it makes you kind of go back and look at your assumptions, look at better ways of justifying it, of explaining it. In the end, it's quite, in terms of the growth of science, if you like, back to philosophy of science, It's actually, it's science working the way it should do, and it's beneficial. Otherwise, you'd get stuck, I'm sure, stuck in a kind of form of religious, what's the word I'm looking for? Not ideology, but nothing would move. It would get in a groove and not be able to get out. But if you're forced to, by challenges, to step outside the groove and say, what more evidence can I find to convince these idiots? Then often you discover things which you didn't expect. Not only do you get a better picture and a more convincing picture, but you actually get one that's got some new, often even more interesting components to it.
Do you think that Oxford tradition of linguistic philosophy and simplifying things makes Dunbar's number particularly difficult to describe to people?
Not really. I think conceptually, it's one of those things. Richard Dawkins once commented that you're right in science when you explain something to people and they go, "Oh yeah, I knew that. I just never realized it." Right? And I think that's absolutely true. And that's one of the classic things I get constantly with Dunbar's number and the circles of friendship, as it were. If you talk to lay people, they just get it straight away.
Yeah.
No difficulty at all. If you talk to people in computer sciences, in social media, in people in Google and those kind of places who deal with the technology involved in these things, they get it straight away. So it's actually been applied in various places. It was used to develop a bot detection algorithm, which is particularly successful. I don't know whether it's used, but it's much more successful than the commercially available ones that the big media companies use to try and root out bot detection. It's very simple. Bots don't have human networks. So if you look at each ego's network structure in Facebook or whatever it may be, you can spot bots a mile off because they don't have this layered structure to their networks. And they don't have 150 in them either. They tend to have a much flatter network structure and to be either very small or very, very large indeed. It's not human. So there are all sorts of applications that have come out of this. So it's actually been applied in a number of cases. I'm told the Swedish tax collecting arm of the Swedish government treasury is reorganized into units of 150. So each tax officer only dealt with 150 people and always dealt with those same ones. So they had personal knowledge.
Are these developments, are they things that you've collaborated with people on, or just sort of none wiser to you that people have just adopted it?
People have just told me about them.
Okay. Is there anything that you would want to apply it to at all?
Yes. NHS.
Okay.
NHS and schools would help great because they've gone off, into Narnia land, basically, both of them, in their desperate efforts to cope with increasing numbers. The idea that you go and see the same GP is non-existent now. But it's the worst thing they could have done. I mean, it was a desperate attempt to try and cope with patient overload. Well, actually, the solution to patient overload is friendships, because something like a quarter to a third of all GP appointments are social. They're not medical. The person just wants somebody to talk to because they live alone. They haven't got anybody to talk to. And if you could solve that problem, you'd solve the financial problem. But and the medics kind of know this, and there's been some discussion about this in the BMJ a few years ago, whether having this sort of cafeteria system, you go along and you go to whichever doctor happens to be free, rather than the one that knows you and has known you since you were not even thought of, because he was your parents' doctor.
Yes. Yeah.
So just doesn't. And so what happens when you go to a GP? They spend you've got a 15-minute slot or whatever it is. They spend the first 10 minutes desperately trying to read your notes on the computer, instead of, in the old days, they wouldn't have needed notes because they knew exactly what, your past history was and what they'd been treating you with. So it's all, the whole system's falling apart because of, in some sense, poor management. So it's, there's a lot of interest in applying these ideas in business organization. A lot of the big management consultants operate with Dunbar's numbers as core to what they do, for example. So, it's interesting, this has always bemuses me because, you get all these ivory tower academics going, no, this can't be right, we'll show it that it's wrong. And then out in the real world, people are applying it all the time. So I kind of go, yeah.